the Bohr's postulates, or given the Bohr's formula, we are trying to calculate the radius or radii of the stationary orbits. So as we know, the angular momentum of these orbits are very stable and very discrete, right? And from Rutherford's model, we have got this kind of concept that the Coulombic attraction force is what is substituting the centripetal force for the electrons to revolve around such stable orbit. So let us now, using Bohr's concept, where Bohr has also told in his second postulate that the angular momentums are in this orbits are very quantized and they cannot take any number as possible. So from Bohr's theory we get that angular momentum mvr for an electron is nh by 2 pi. Suppose an electron of any particular element which has a z number of charges. So z is the atomic number of that particular element, and z number of electron is there at its center, and the electrons are revolving around in this particular orbits around the nucleus. So therefore in various different orbits there are different number of electrons, but we are looking at a particular electron, suppose this, and this is at a distance from the nucleus which is r. This electron is moving with a velocity v and it has a mass m, right? So we are looking at a particular electron that is revolving around the nucleus, and the nucleus has z number of positive charge, the same as the electron. So this is E and Z is the atomic number. So as we know that the Coulombic force between these two will be 1 by 4 pi epsilon naught Ze into E by r square. The distance between them is r square, r. And for electron to move with a velocity v and with a mass m, the centripetal force will be mv square by r. So from here we know that mv square by r is equal to 1 or z e square by 4 pi epsilon naught r square. So r square r gets cancelled, or we can just write mv square r is equal to z e square by 4 pi epsilon naught. So this is what we have already got from Rutherford's concept. Now as we know that if this electron is moving in this particular orbit, then it will have an angular momentum which is mv into r. So this is the angular momentum for this particle that is moving around, which by Bohr, according to Bohr theory, is nh by 2 pi. So we can write that mvr is nh by 2 pi. So from here it is mvr is nh by 2 pi, or v is, can just take out the v, is nh 2 pi into m into r, right? So this velocity that we have got, we are going to substitute here. So m in the place of v square, n square, h square, 4 pi square, m square, r square into r is equal to z e square by 4 pi epsilon naught. So this, we are just taking v out from here and substituting it here. So m here and m gets cancelled, r square and r get cancelled, 4 gets cancelled, pi square, pi get cancelled. So from here we have to, since we are looking at the radius, we have to look at r. So I am bringing r at one side and taking all this at one side. So r comes here, and here n square, h square is same, 1 pi is there, m is there, r has come this side, epsilon naught goes here and this becomes z into e square, right? So this is the equation for the radius. Now here we know that almost everything here is a constant, so we can write this in a better manner. This is n square h square epsilon naught pi m z e square. So this is the constant where n will depend on which orbit we are talking about. So every orbit also cannot have any radius, it's possible. So every orbit will be situated at a particular distance, at a particular radius from its center of nucleus. So n, if it takes the value 1 for the first orbit, n equal to 1, and if we are talking about hydrogen atom, then for hydrogen atom z also becomes 1, and therefore this becomes 1, z becomes 1, then this whole this one is 0.5 angstrom. So this is 0.5 angstrom, which is the first orbit of hydrogen atom. So this is also called as Bohr orbit, right? So thereby what we see that these stationary orbits also cannot be situated at any distance as the electrons wishes or anybody wishes. It will have a particular radius and will have a particular distance based on this formula, and where n can take value from 1, 2, 3, 4 and so on.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.